Category 2 is all about evolving science. And the emphasis here is there are often ethical or logistical or other reasons that we can't go to complete endpoints in testing science in this category. So for example, if we want to know the effects of no protein in a diet, it's unethical to take human beings to a month's worth of no protein, right? So we have to extrapolate, and then sometimes we have to interpolate. But science that has found itself in this category is still very respectful. It's category 2, evolving science. And there may be reasons that we can't take to an endpoint or to understand completely through trial and error. At the bottom, what we list are predictive models. And so I'm going to give a couple of examples of how medicine uses rationalized science. Personal example, the Agency for Health Research Quality works for HHS. They're all about evidence-based medicine. They're all about screening and diagnostics. So there was an argument made to AHRQ that we ought to be routinely screening people for glaucoma. Sounds reasonable, right? Well, there's a cost to that benefit. The argument that the Federal Advisory Committee to AHRQ made was you don't have the evidence to basically say you've got category 1 level support for making the screenings affordable. It turns out that as you analyze that literature, it makes all the sense in the world for screening minorities, both Latino, Hispanic, as well as African Americans. Because of the signal-noise ratio associated with those subcategories, you make a lot of money screening and then getting them to a diagnosis. But for the general population, they're correct. The evidence base is at net, you lose money by screening everyone and then sending them to diagnosis if they screen. The second example of category 2, generally category 2 science, is very, very interesting. I have the privilege, as mentioned before, of teaching in the medical school at Georgetown University. And in one of my classes, we basically tackle nutrition. You would be very, very surprised how category 2, at best, nutrition science is. So let's walk through the actual science of nutrition. And remember, you've got ethical and other restraints on what you can do in terms of scientific experimentation. So during World War II, the observation was, heck, we've got troops, over there. What do we need to send them? How do we feed them? And so the president consulted the national academies, which was the right thing to do, who then said, you need to get busy with this. So the president did, and basically directed the Department of Agriculture to go figure out what we need to send the boys. Well, the Department of Agriculture at that time was not what the future FDA would be. It was not about safety. It was not about health. It was agribusiness, as it is still today. And so the Department of Agriculture, bless their hearts, figured out, okay, here's how many calories we need per day, roughly 15 calories per pound of body weight to maintain body weight. But those guys are fighting in a war, and women, and so the calorie count was higher. And they came up with something very, very important to us called the Recommended Daily Allowance, the RDA. Recommended, not required. Daily, we understand. Allowance, not allotment or anything else, but an allowance. And essentially the Midwest became the king. It was all about getting corn from the Corn Belt through our Department of Agriculture, ultimately to our troops. But the most important thing that came out of this category 2 at best trajectory was called the food pyramid. Someone, I honestly think, woke up in the middle of the night drunk, said, I got it, food pyramid. Let's go now populate the food pyramid, right? And we've been fighting about how to populate the food pyramid since that time. And my argument as a scientist is we need to back off from the food pyramid assumption. Maybe there's no pyramid there, okay? Maybe there's nutrition whose physiologies was served during Pleistocene, which is exactly the physiology that we have today. They didn't know about food pyramids then. They just ate what they needed to survive. What is the physiology and the requirements for nutrition based on that? Let me give you some examples to confirm what I'm trying to claim. What is your daily requirement for vitamin C, ascorbic acid? What would you think? Well, very credible indications from FDA and other very reliable sources vary from 45 milligrams a day to 12,000 milligrams per day. Yeah, how many orders of magnitude is that? These are credible sources that I've looked up, okay? And they vary based on, well, if you're trying to prevent a cold or get rid of a cold, to just your daily inability to synthesize ascorbic acid, here's how much you need to supplement your diet with. 12,000. What scientific research is that based on? My class took this on, as with every other vitamin and mineral that we're told we need to be paying attention to, and they found that the requirement for vitamin C came from, essentially, you go all the way back, one empirical study based on, I think it was 6 very healthy Caucasian males. And that's one of the best findings that my class found. These were graduate students, medical and Ph.D. students at Georgetown Medical. So what I'm saying here is nutrition science is at best category 2. It's rationalized, meaning very trusted minds, very smart people have made declarations about how much protein, how much vitamin C and other things that we need on a daily basis. But if you, as a skeptic, say, you know, I hear you, Pritikin, I hear you, whoever, I'm going to go to the original literature and I'm going to look it up. Who experimented and how and what were the results? And if you do that the way my class did and I did, you're going to be shocked. You'll be absolutely shocked. But people get very good at being preachers about nutrition, you know, and it sounds very attractive, and I'm going to talk about the lure of mechanism in a few minutes. They sound scientific, but when you say stop, slow down, what experiment was done, when, where, and how? What were the results? Now we come to category 3 science in our view, and this is sort of borderline. Yes, sir?
Obviously, you looked at the data. Presumably, you would find other data. Is there a better range that you would deal with than 45 to 12 milligrams, or 12 grams?
12,000 milligrams. Right. Do I know a better answer?
Yes.
No, sir, I don't. And as a scientist, I would look to those who've actually done experiments, and with the limitations of ethics that say, well, we're not going to keep a laboratory rat deprived of vitamin C, or we are going to, looking at other mammalian specimens. So, so here, for example, borderline science, models of stock market activity, which are purely empirical and are not theoretical, is what we're talking about here, is an example here. Now, this is still respectful. I mean, we're talking scientific judgment as category 3A. Often an educated guess, sometimes that's the best that you can do, you know. And so what we're saying is this is not being judgmental. If we rank a particular trajectory as being category 3, that's okay, but we need to say this is best that we can do right now. And policymakers, you need to understand that we're only at category 3 when you make a decision about whatever it is, global climate change, you name it. And we're going to use that as a case example in a few minutes. The last time I tortured you in this room, I talked in length about shaken baby syndrome and how it is, in one sense, you can argue that it's some category 2, but is in fact, I think, category 3.